A gear train is a fascinating mechanism that efficiently transmits power from a driving shaft to a driven shaft through two or more gears. Let's break down the four main types. First, we have the simple gear train, where gears are directly connected in a single line, making it straightforward and easy to analyze. Next is the compound gear train, which combines multiple gears on a single shaft, allowing for greater speed reduction and torque multiplication. Then, there's the reverted gear train, where the output shaft is aligned with the input shaft, often used in compact designs. Finally, we have the epicyclic gear train, where gears rotate around other gears, offering high efficiency and compactness, ideal for applications like automatic transmissions. A simple gear train consists of a series of gears where each shaft holds just one gear. This design is fundamental in mechanical engineering. The beauty of a simple gear train lies in its straightforwardness. The velocity ratio can be easily calculated. It's simply the ratio of the number of teeth on the last driven gear to the number of teeth on the first driving gear. For instance, if the driving gear has 10 teeth and the driven gear has 40, the velocity ratio is 4:1. This means for every rotation of the driving gear, the driven gear rotates a quarter of a turn. Idler gears play a crucial role in gear systems, acting as intermediaries between driving and driven gears. They fill the space that might otherwise be wasted, ensuring a more compact design. But their function goes beyond mere spacing. They also change the direction of rotation. When you have a driving gear turning clockwise, the idler gear will turn counterclockwise, and this, in turn, influences the direction of the last driven gear. This is particularly useful in applications where the orientation of the output shaft needs to be different from the input. Let's break down the rules of gear rotation. When you have an odd number of idler gears, the first and last shafts will rotate in the same direction. Picture this. You have one idler gear between two shafts. The motion transfers through the idler, resulting in both shafts spinning in harmony. Now, if you introduce an even number of idler gears, or even none at all, the scenario changes. In this case, the first and last shafts rotate in opposite directions. Imagine two idler gears in between. Each one flips the direction of rotation, leading to a complete reversal by the time you reach the last shaft. The main drawback of simple gear train is its large overall dimensions and weight. A compound gear train is one in which at least one shaft carries two gears. In a compound gear train, the intermediate shaft has two gears, one meshing with the gear on the driving shaft and the other meshing with the gear on the driven shaft. Compound gear train is compact in construction compared with simple gear train. When the number of teeth on various gears in a compound gear train are selected in such a way that the center distance between gears 1 and 2 is equal to the center distance between gears 3 and 4, then the driving and driven shafts can be located on the same center line. This type of arrangement is called reverted gear train. An epicyclic gear train is a gear train in which one gear is fixed and the meshing gear has a motion composed of two parts, namely, a rotation about its own axis and a rotation about the axis of the fixed gear. This type of train is also called a planetary gear train. The fixed gear is called the sun gear, while the revolving gear is called the planet gear. In this arrangement, the sun gear is the driving gear and the crank is connected to the driven shaft. The crank is also called the planet carrier. In some arrangements, there are 3 planet gears and a fixed ring gear. The epicyclic gear train has compact construction.